when I calculated the worst case scenario for my case, and I consider the probability of that, and after that I decide if it is worth it or not. But worth for what? The best case scenario, because when you check the worst case scenario, usually on the other side you should check also the best case uh, scenario, because you will notice that is it worth that best case scenario with all the risk and worst case scenario that can impose that amount of loss on you. So that's the reason you can find it in literature when they talk about decision science. They have worst case scenario, best case scenario, and most probable. And it is a very common type of analysis in real world. But in this class, we are not going to discuss it because now we are doing together simulation that is way more reliable than this type of things, that worst case, best case. We are going to handle our problem, our case with simulation that is way more sophisticated than that type of things. But I found it good to be reviewed in an activity and to be discussed as just we did. So let's get ready for the final simulation that we have. To be able to do your final simulation, like the experience we had with Excel solver, it is not mandatory that you have this structure that you see, for example, the color or this thing. No, it is just a way of making it stood out in the spreadsheet you are making for the problem. And so it would be my recommendation you make similar things in your Excel sheet. And as you can see, we have one column for the number of for the runs that we have for the simulation. And since we have 1000 runs, so here we should have 1000 rows. After that, we have selling price per unit. After that, administrative and advertising cost, and they are going to be fixed. Direct labor cost per unit, it is going to be a random variable. Parts cost per unit, again random variable. And first year demand, and after that you put the formula here to calculate it. And when you do these things, after that you run it for 1000 times, and that's it. And we are going to do it step by step together. So at this step, please pause your video and create some sort of similar structure in your Excel sheet. Okay, my friends, here you can see the simulation table I designed in my Excel sheet. And similar to the PowerPoint that I showed you, I prepared all these things. We have 1, 2, 3, 4, 5 of the parameters that are important, and the final things that is profit to help us with the decision making. And here also we have run to help us with 1000 cases of simulation. So it would be something like this. And you see, it would be this much simple. Preparation of Excel sheet for simulation is much easier than Excel solver because it is directly related to the Excel sheet. There is no another adds-on or anything. And very soon you will see all these details. Now that we have our table structured, we can go for filling of this table we have. Okay, to fill out our table, we start from the first run, because after that it would be the matter of copy and paste, the matter of dragging all the formula to the following rows. So selling price per unit is fixed number. It is 249. So we put it over here. Administrative and advertising cost. Here there is a typo. It should be 1 million. Now I'm going to show you in the Excel file. And direct labor cost per unit is going to be the first one that we are going to do the simulation. Random number generation. Last week we talked about how to generate random number regarding direct labor cost per unit. So on the right you see I have assigned a column for random number. And remember, my friends, any of the things that we do here, since it is not a serious, it is not a real experience that we must prepare report on that. So just feel comfortable in freezing or not freezing them, because as I told you before, it continuously refresh itself. So it is something that you can control easily. And for this case, I'm gonna show you with freezing, so you can see the case, because when you want to freeze your random numbers, you need to take extra steps for that. So I guess in terms of learning, it would be better to show you that with the freezing one, and we are going to discuss it more. So at this time, please pause your video and please do it yourself. What we learned together last week, that how to generate random number for discrete probability distributions. So according to that, please simulate the direct labor cost for the first year, for the first run, in fact. Here we are going to create the random function results in a frozen way for direct labor cost. So here I have this generation of random number for 1,000 cases that we have. And just the problem with this is the fact that it refreshes itself continuously. And as we discussed this before, you see, anything that I do anywhere, for example, I type A here, it refreshes itself. So what I need to do, I need to froze it. There are many ways to do the freezing, and it is the easiest way to do it. If you are good with Excel, of course, you know some other ways to do that. Okay, and here we go for pasting, and paste only for values. And now we have the random numbers here, pasted. And now when I refresh my page, as you can see, that side is completely frozen. So I'm gonna delete this part. And remember, this random number that I have made here is only for direct labor cost. Because if you use one set of random numbers for all of when I say random numbers, let's call it rand. When you use one rand for all of the random numbers that you have, it makes your result biased. So you need to make a rand column for each of them. And remember, again, I told you, it's not a real problem that we are doing, and you need to prepare a report on that, and the numbers and the relation between your report and numbers is important. It is just the learning experience, and just for learning objectives, I showed you how to freeze it. And for the rest, I'm not gonna freeze them, but if you like, you can freeze them. And also for your homework, you just need to freeze them for one to show me you are good with that process. That's it. And now we have ran. And now when we have ran, we can fill out the direct labor cost per unit random number. But you may ask, what about selling price production? There is no need for uh, generating random number. It is fixed. And about the administrative cost, it is 1 million. So I quickly put them here. And since for 1,000 cases, we can take them together. Since for 1,000 cases they are the same, now I can fill it out like this. And another point that I should tell you, and it may strike you, that is it necessary that when it is fixed we assign it a column? No, it is not necessary. Very easily you can do this simulation without this column and this column, but you should be careful about the formula that you make here. Absolutely, I'm telling you, it is not necessary, and even it is not recommended really, because it is just for the educational purposes, and I want to show you everything. So the next step, we are gonna fill out this part as the random number related to direct labor cost. So please pause the video if you have not done that before you see the results here. The formula for direct labor cost now inserted, and I got the results. And this, the formula that I used here, is the formula of if-s, different from the one that we used last week, and also the one that is on the PowerPoint. Now I'm just gonna show you the formula, that if you are more comfortable with this, you can use this one for your future references. It doesn't make any difference, so don't worry about which one. It is just using if-s. And but last week and also in the PowerPoints we have nested if statements. And the most important things is that you connect this direct labor cost and random numbers correctly. And now we got it, and I just can copy and paste this for the remaining 1,000 cases. So this much quickly. We got 3 columns of our simulation done. So we just need to do the remaining 3 columns to call it a simulation. The same way you populated the column related to direct labor cost, you should populate part cost per unit. But the difference is that the part cost per unit is a continuous uniform distribution, and it is, I believe, easier than discrete distribution to do, and you don't need to do freezing. Just put the formula here and drag it down for 1,000 cases. I put the associated formula here as we discussed it last week, and also you can see it in the PowerPoint, 80 plus 100 minus 80 times rand. And now you have random numbers between 80 and 100, that is parts cost per unit, and it is uniformly distributed. And now we can drag it down to the rest of case runs that we have. And I didn't freeze it. Let me show you. You see, it checks. It changed.